dream about that our teacher dressed like a nerd on the thing?
Sure.
Our teacher is dressed like a nerd. Woo!
All right. Okay, so we are now in Unit 2. So I've set up the semester, so there's 4 units, so 25% of the way there.
So we're not 25.
Huh? You're being done with the trade.
So can we just see like 100% done and not have?
No. So your test is on Thursday. Yeah. So we're going to start graphing these trig functions we've been talking about. Maybe.
Oh, I can't do it. Where are you dominant?
Yes, we can do it, Mr. Picker.
Yes. And I'm going to go through this slow, just based on past experience. So for some of you, those of you who have already dealt with trade, this would be really slow. That's okay. You can just get an A. So right now we're going to talk about sine functions in this form. Y equals A sine of bx. So the A stands for amplitude. It's how far above and below the sine function will be above and below the x-axis. Not always. In our regular plain old sine x, the amplitude is 1. So I'm going to graph this plain sine right now. And the letter B helps us find the period. The period is how far the sine curve travels before it completes one curve. One curve looks like this. To find the period, we do 2 pi divided by that b. In the regular sine of x, b is 1, so the period is 2 pi over 1, which is just 2 pi. That means for every 2 pi, we'll travel a sine curve. Okay, so I like to do this using tables. You don't have to. If you're quick with graphing these functions, that's fine, but if you're struggling, I would recommend using a table. So for our purposes, I'm going to start at 0. And to complete the entire one period of the sine function, I'll end at 2 pi, because the period is 2 pi big. And I'm going to use our other quadrant angles that we've been using. I'm going to use pi over 2, pi, and 2 pi over 2. So those would be our x values. Our y values we'll find just by finding the sine at those angles. So the sine of 0 is, anybody? Sine of 0 is 0. The sine of pi over 2 or the sine of 90 is 1. The sine of pi is 0. 3 pi over 2 is -1. And the sine of 2 pi is 0.
They're saying it's off the units. Alright.
That's right. So this comes from our points on the unit circle, the quadrant points. So you can see that our amplitude of 1 is going to make this graph go 1 unit above and 1 unit below the x-axis. And just for visual sake, I'll make each unit up and down worth half. So 2 units is going to be 1 for me. So sine is a continuous periodic function, which means it's going to continue doing that forever and ever in both directions, and it's going to follow the same pattern. So when you start your practice, they're going to ask you to graph 2 periods from negative 2 pi to 2 pi. So all we have to do is follow the pattern backwards. And we can complete another period of sine. Okay, so once you have 1 period of sine graphed, you can just continue going as far as you want to. So I would say for the next couple weeks, it might be handy to have some graph paper on hand. So if you don't have it today, bring it with you for now. So you can make nice, pretty, neat graphs. Okay, and also, this is an art class, but don't draw your sine curve like this. Okay. Sine curve is curved, it's not a V or a W. Okay, we're not making the mouth on a pumpkin. Make it curved. So I'm going to carve a pumpkin this year with a sine curve mouth. Alright. So we're not going to graph just regular sine. We're gonna change it up, and we're gonna squish it, stretch it, and all that stuff. So the first thing I want to do is change the amplitude. So we're going to graph y equals 2 sine x. So the letter for B has stayed the same, but the letter A changed from 1 to 2. So that means my amplitude's now 2, my period stayed the same because B stayed the same. So I'm still going from 0 to 2 pi. Again, if you don't need the tables, don't use the tables, but I advise you to play along if you don't know what you're doing. So my x values are not changed because my period stayed the same. I'm gonna put down here my original sine curve y values. So we won't graph those y values, we're going to use them because the way to get our new graph, the y values, is just multiply these by 2. For plain old sine x, yes. So, it might be cool to graph this the same as you know. So I'm going to graph regular sine x real quick. The one that we just did. And now I'll graph y equals 2 sine x. And I'll be so you can see the difference. They start and end in the same spot. They hit the x-axis in the same spot. But their inflection points are stretched up and down, further above below the x-axis. Alright, so I want you to try y equals 4 sine x. Okay, so your period should stay the same. Your amplitude is going to change to be 4. So now we're just 4 units above and 4 units below the x-axis. That's the only thing that changed.
Before we do the amplitude and everything, because that determines how much up or down you have to go, what does the period do?
The period tells you how long it takes for that curve to be completed.
So do you mean that's actually correct, the equation?
Yes. I'm going to change the period on the next page. Any other questions? Okay. So now let's change B instead of A. So if we're graphing y equals sine of 2x, our amplitude goes back to being 1 because the number in front of sine is 1. And our period changes. We plug in b here, which is 2. Those 2's cancel, and our period is pi now, so it's half as big. So that means we're going to complete one of our curves between 0 and pi.
Are you splitting it over 2 because it's 2x? Or
Yeah, I'm taking the number in front of x, and that's b. So I
Yeah.
plug it into 2 pi over b. And I added an extra column. I didn't really need that. Okay, so for now we're just starting at 0. And our period's pi, so we're going to end at pi. Here? I got to figure out what goes there. So I'm dividing pi up into 4 intervals. So for each of these, I had 4 intervals between 0 and pi over 2, pi over 2 and pi and 3 pi over 2, 3 pi over 2, and 2 pi. So we have 4 quadrants. We're going to deal with 4 intervals. So our intervals are going to be different because our period is different. So I'm just going to take the period and divide it by 4. And that's going to tell me how big each interval should be. So starting at 0, I'm going to go up by pi over 4. So after 0, I go to pi over 4. Then I go to 2 pi over 4. You can also call that pi over 2. Then I'll go to 3 pi over 4. And then if I go up pi over 4 more, I get 4 pi over 4, which is just pi. So I have equal spaced intervals. I'm starting at 0, my period's pi, so I'm ending at pi.
How do you know it's pi to use pi over 4?
How do I know to use pi over 4?
Yeah.
I took the period and divided it by 4.
How do you know what you do?
Because if we start with the original sign, we have 4 intervals.
Okay.
1, 2, 3, 4.
Okay.
So we want the same thing. Each of these is going to represent either an x-intercept or an inflection point where the graph turns. And then our y values stay the same. Okay, so that you can see how this changed the graph, I'm going to try and fit it. So that's where pi was on my original graph. So 3 pi over 4 is somewhere around there. This would be 2 pi over 4, pi over 4 somewhere around there. So it just squeezed or scrunched up my graph. It still goes one above, one below, but it's pushing it tighter together. So actually by the time I get to 2 pi for this one, I'll have already made 2 periods worth of my graph. the amplitude changes how high and low it goes. The period changes how spread out or compact the graph is. So give y equals sine of 4x a shot. Okay, so the bigger I make b, the smaller my period gets, and the more compact my graph gets. I'll tell you. So the amplitude stays the same. I plug in 4 for b. So 2 pi over 4 simplifies to pi over 2. That means my sine curve is completed in a span of pi over 2. So I'm starting at 0 again, and I'm stopping at pi over 2. So I should have my curve completed by pi over 2. Right, so the way I find out these values is I divide the period by 4. So pi over 2 divided by 4. I'm dividing up this period of pi over 2 into 4 equal intervals. So each interval is going to be pi over 2 divided by 4. Okay, the real quick and easy way to handle pi over 2 divided by 4 is to just slide this 2 down here and multiply it by 4. So each of the intervals is pi over 8b. Okay, I'm willing to bet that the two places where people make mistakes are getting the intervals and these values. So you should memorize these values, and then the intervals is a little bit of handling fractions. So if I start at 0, I add pi over 8. Then I add another pi over 8, so that's 2 pi over 8. Another pi over 8 is 3 pi over 8. Another pi over 8 is 4 pi over 8, which is just pi over 2. And then I go ahead and graph my points. So one of the reasons why I'm breaking up graphing these functions is because eventually we're going to slide this sine graph to the left and the right and up and down. And this part is going to get a little messier, so we need to be comfortable with this to start with.
Is there ever going to be a time we're going to get like 4 sine 4x?
Cool. So try that one. We're going to just put them together. Okay. So our amplitude is -2. So that's going to change how far above and below the x-axis we go. It's also going to change how our curve looks. It's going to look reflected. That's what the negative does. Our period changes. We take the 3 and we plug it in here for b, and we get the period to be 2 pi over 3. So that means between 0 and 2 pi over 3, we're going to do one sine curve. So my x starts at 0 and it ends at 2 pi over 3, just for one period.
Just out of total curiosity, is there any possible way to do some calculating?
No.
What was the question?
Okay, so how do I get these 3 numbers? Because these are the 3 numbers that trip people up. I take the period, 2 pi over 3, and I divide it by 4.
So every time you divide it by 4.
To find these interval values, yes. So I divided 2 pi over 3 by 4. It gave me 2 pi over 12. And we always simplify if we can, so it became pi over 6. That means each interval is pi over 6y. Because I'm divided, I want 4 equal intervals.
So if you wanted 6, you want to use the 6.
Think about 4 quadrants in the unit circle. So we start at 0, we hit quadrant 1, 2, 3, we're back around in the 4th quadrant. So we had 4 equal intervals. So my interval width is pi over 6, yeah. Yes. So I start from 0, I go up pi over 6, I go up another pi over 6, which is 2 pi over 6. It's the same as pi over 3. I go up one more pi over 6, and then one more pi over 6. 4 pi over 6 is the same as 2 pi over 3, which is where we should stop for one period.
Wait. Could you simplify 2 pi over 6?
Yeah, I could.
How about inch?
For these ones, I wanted them to look uniform, just to save some confusion right now. Yeah, I should make that pi over 3. Should. So I'm not going to attempt to squeeze this one in. So on a test or something like that, a quiz, you need to make sure you're very explicit about your labels. Because you might want to make yours bigger because it's easier for you to graph that way. You might want to shrink it down because it's easier for you to graph that way. So make sure you're labeling your axes so I know that you're hitting the correct points. So if you graph it that way, it's going to look very much like -2 sine x, unless you make sure that you label your axes correctly. So I'm using these for my y values. Why it's 4 down. Well, I just wanted to make it nice and big. So I made 2 of these blocks, one. So instead of doing 1, 2, I did 1, 2. There's no technical reason. I just wanted to make it nice and big. So the negative reflects that thing. The 2 stretches it above and below the x-axis, and the 3 technically shrinks it. I didn't want to mess with thirds and sixths on that graph. Any questions? Nothing for now. So there is more to graphing sine, but we're going to hold off a couple days on that so we can practice this. So I have 5 practice problems for you. When you're done, make sure your name's on it and turn it in to me. I've killed off Todd. He's gone. When we're on, I'm gonna just start collecting your practice.
Isn't that kind of illegal?
Why did you stop
Killing off.
Because people weren't doing the work.
That's so sad.
I want you to have a more accurate reflection of how you're doing in your practice.
You need to have a point.
And yes,
I was doing my work.
I don't know.